Now we are going to do two questions on errors and uncertainties. So in question 1, the diameter of a wire is given as 0.56 plus minus 0.01 millimeter and cross-sectional area has been asked of that wire. So when we go towards the solution, first of all we apply the formula of the area of circle, which is pi r square, which is also equal to pi d square over 4. Here the diameter is given, so pi d square over 4 has been applied, values have been put in, and the area has been calculated as 0.2463 millimeter square. As the diameter is uncertain, as it has a plus minus in it, so we have to find out the uncertainty of the area as well. So we go on to the fractional uncertainties directly. Please remember that any powers given to the quantities will always be multiplied to the fractional uncertainty. So here in the area calculation, there is a d square, that is d has a power of 2. So fractional uncertainty of diameter will be multiplied with 2, as I have explained in the red color. We put in the values and we find out that the uncertainty in area works out to be plus minus 0.009 millimeter square, and we write down the answer. Area is equal to plus minus 0.246 plus minus 0.009 millimeter square. Going on to question number 2, an experiment has been described in question number 2 in the lab, where a voltmeter and an ammeter was used to find the resistance of some circuit, and the voltmeter and ammeter reading are shown to you. The voltmeter reads 3.00 plus minus 0.03 volts, and ammeter reads 4.9 plus minus 0.1 milliamperes. Here two things again are of very interest. Can you see that voltmeter is up to 2 decimal places, so the uncertainty is in the second decimal place, and ammeter reading is up to 1 decimal place, so the uncertainty is also in the first decimal place. Okay, you have to remember that. So we have to estimate percentage uncertainty in resistance of the circuit, 3 marks, and find the resistance and its uncertainty, again 3 marks. So when we go for the solution, we also know that there is a Ohm's law which says that V is proportional to I, and V is equal to R, IR, V is equal to IR, and R is equal to V over I, because here we are to work out the resistance. Remember that in uncertainty questions, you should always go for the equation in which the fractional uncertainties are equated. Here the fractional uncertainty in R will be delta R over R, and fractional uncertainty in voltage will be delta V over V, and so will be delta I over I. And for percentage uncertainty, we have to multiply the fractional uncertainty totaled up and multiplied by 100. So delta R over R multiplied by 100 will be equal to plus minus delta V over V plus delta I over I, bracket close, into 100. and we'll get the percentage uncertainties. Putting in the values, and we always write down plus minus before the uncertainty. 0.03 divided by 3.00 for voltage and 0.1 divided by 4.9 for amperes, and multiplied by 100 after the bracket, we get an answer 3.04%, or we can write down the percentage uncertainty in the resistance is plus minus 3%, and you score 3 marks. Going on to part 2, we have to work out the uncertainty in the resistance, not the fractional uncertainty which we have already calculated above, not the percentage uncertainty which we have calculated above. So we write down the formula, and before going on to the uncertainty in resistance, we work out the resistance also from the equation R is equal to V over I. Putting in the values, you must remember that ohm is a base unit for resistance, which is being worked out from the base units of voltage and amperage. So amperes are in milliamperes, so we must convert it into ampere. The value of milli is 10 power minus 3, so I write down 10 power minus 3 multiplied by 4.9, and resistance works out to be 610 ohms. Now it's easy to put in the values, and then we make delta R the subject of the formula, and we work out it to be 18.6 ohms. Therefore, R will be written as 610 ohm plus minus 18.6 ohm, but the uncertainty is normally written in one significant figure, so we work them out and write down 6.1 plus minus 0.2 into 10 power minus 2 ohms is the final answer, and we get 3 out of 3 marks here as well. I hope that you have understood and liked my working and explanation. Kindly like my channel and prescribe. Thank you very much.